All right, so today we're going to talk about calculating percent composition by mass. And this is molar mass in disguise. Because really what we're taking a look at when we take a look at a compound is saying what percentage of the compound is going to be made up of calcium and what percentage of the compound is going to be made up of chlorine. And this is going to be a product of the molar mass that we talked about yesterday. Remember, with molar mass, we need to add up the pieces from the periodic table. And so the first step in finding percent by mass is to add up the pieces from the periodic table. In your Google Doc, you're going to have little cells that you can type in each one of these cells. So the first problem I'm going to do is going to look like your worksheet. And then the second problem I'm going to do is what I'm just going to handwrite on paper. So when we take a look at percent, what do I know about percent? Well, all percents are basically the same. A percent is always going to be some part that is going to be divided by a whole, and we take it times 100. And if I'm taking a look at percent by mass of a compound, it's the same thing, but my part is going to be the mass of the atom in the compound. And what is my whole? Well, my whole is the molar mass or the mass of the compound. And then like any percent, we take it times 100, and that will tell you the percent by mass of that element in the compound. So the first step in this is really to find the molar mass. And this should look like a lot like what we were doing yesterday. So in this compound, I have calcium and I have chlorine. And how many refers to how many pieces. That's the subscripts. If I look next to calcium, there is no number here. And that means that there really isn't anything but one piece of calcium. Now, I did have kind of a common mistake that this 2 kind of tends to migrate over here, but we don't do that. That 2 is very specific. That 2 belongs only to chlorine. So I have one piece of calcium here, and I have 2 pieces of chlorine. The mass of each atom comes from my periodic table. So I can go down to my periodic table and I can find calcium, and I can find chlorine. And I can take the mass of calcium, which is 40.08. I can take the mass of chlorine, which is 35.45, and I can bring those up here. Now, the one thing that's different from your worksheet from yesterday is this column right here. It is the total mass of each element in the compound. Oops, I want that to be yellow. Because that's the part that I'm going to fill into my percent problem. That's the part that I'm going to put on the top of the line. So what I'm going to do is I'm going to take 1 times the 40.08, and that's just going to come up with 40.08. I'm going to take 2 times the 35.45, and that's going to come up with 70.90. And those are the numbers that I'm going to use in my percent problem. So the mass of the compound is still the same. I'm going to add these 2 together, and that's going to come up with the mass of the compound. And I will remind you that Google has a fantastic calculator. If you don't have one and your cell phone doesn't work as a calculator, okay, it's not letting me switch to my Google calculator. Go to Google Calculator, and there's one right there for you available to use. So this is going to be 40.08 plus it's going to be 70.90, and I'm going to come out with 110.98. And units are important, so make sure you're putting the grams per mole. So now if I'm going to take this and turn this into a percent problem, there's 2 parts because there's going to be percent of calcium in this compound and there's going to be percent of chlorine in this compound. So on your worksheet, it'll say first element. Well, I'm just going to assume that the first element is going to be the first one that you put up here. And your worksheet's going to say second element, and that's just going to refer to the second element in the compound. And if there's a third element, there will be a third table for you to type in. And again, you can directly type into these squares so that the mass of the first compound, well, that's going to be the number that I came up with here. So I am going to take this number, this 40.08, and put it here because in this compound there were 40.08 grams of calcium. Okay, and I'm going to divide that by the mass of the compound. So that's going to be this piece right here. So I'm going to take this mass of the compound and I'm going to fill that in down here. So I'm going to take this 110.98, which is the mass of my compound. Now, trying to do this digitally, yes, on your worksheets, you can imagine this line as your dividing line. And what am I going to do? I am going to take 40.08 divided by this 110.98 times 100 to get the percent of calcium in the compound. So it's 40.08 divided by 110.98 times 100, and I'm going to come out with 36 and a whole bunch of decimal places. For our problems, I want you to give me 2 decimal places, please. Well, with 2 decimal places, I'm going to use standard rules of rounding. And standard rules of rounding, I've got 0.114, so I'm just going to say 0.11. So second part of this problem, that's my percent of calcium in the problem. Now I need to find my percent of chlorine. And my percent of chlorine is very similar. I'm going to take this 70.90, and that's going to become the mass of chlorine in the compound. No, don't just take the standard mass of chlorine because I need the amount that's in the compound. And I am going to divide that by the total mass of the compound. So this 110.98, and I'm going to take it times 100. So in my calculator, I'm going to take 70.90. I'm going to divide it by 110.98 and take it times 100. And standard rules of rounding. So I have 63.885, and 5 means I round up, so I'm going to say 89%, and this gives me the percentage of chlorine. Now, all percents should equal 100. And if all percents equal 100, then yes, actually I add these up, and these are going to come out to be 100%. But just a side note, because of rounding, it sometimes ends up being 99.99%, and sometimes it'll end up with 100.01%, and that's still pretty close to 100, so we're fine. So the second one I want to take a look at, and I didn't put any fancy tables here because I'm just going to handwrite this, is magnesium nitrate. And magnesium nitrate has the parentheses, and there was definitely some confusion about how to figure this out from yesterday's worksheet with some people. So let's take a look, and I have magnesium. And remember with the polyatomic, I've got nitrogen and oxygen together, so I have to break those apart into the nitrogen and into the oxygen. And as far as counting these, well, there is no subscript by magnesium, and magnesium is not in my parentheses. So these are sacred, and magnesium's not part of it. So this 2 has nothing to do with magnesium. Instead, yes, I've got a 2, but that 2 is only going to apply to what's inside the parentheses. So the nitrogen and the oxygen, and magnesium's not part of that. So magnesium doesn't have a subscript, and that means that it has 1 piece of magnesium. But nitrogen and oxygen are in the parentheses, and that means that they're both affected by this 2. And so really what that means is I have 2 times the nitrogen and 2 times the oxygen. But a second way to look at it is I have 2 pieces of NO3. So if I write out 2 pieces of NO3, it actually makes it a little bit easier to see how many pieces I actually have. So I can take 2 times the 1 nitrogen, and that's going to give me 2 nitrogen. But if I write out NO3 twice, I can pretty easily see that there's 2 pieces of nitrogen there. And I can take this 2 times the 3 to come up with 6 pieces of oxygen. But if I have this written out, I can see 3 and I can see 3, and that must be 6 pieces of oxygen. So 2 ways to be able to do that. Both you're going to come out with the same answers. If you're more visual, this might be preferred. If you're less visual and you're more mathematically inclined, then the distributive properties probably work pretty well for you. So once I have the number of each atom, I need to go down to my periodic table and I need to find the mass of each atom. So I have magnesium? Yeah, I've got magnesium and I've got nitrogen and I've got oxygen. And so the mass of magnesium is going to be 24.30. The mass of nitrogen is going to be 14.01. And the mass of oxygen is going to be 16.00. So I know this is going to be 24.30. This is going to be 14.01. And this is going to be 16.00. And what am I going to do? Well, I am going to multiply. But that new column, and this is the column that I need to be able to solve my problems for today. That new column is the total of the atom in the compound, because that's what I need to be able to do my percent problem. So 1 times 24 is going to give me 24.30. And 2 times 14 is going to give me 28.02. And 6 times 16 is going to give me 96.00. And these are the numbers that I'm going to fill into that formula for the top part of that formula to find the total mass of the compound. I just need to add these pieces up. So in my calculator, I am going to take 24.30 plus 28.02 plus 96.00, and I'm going to come up with the total mass of the compound, which is going to be 148.32, and this is going to be grams per mole. Now, if I'm going to find the percent of magnesium then, it is going to be the part of magnesium in the compound. So it is going to be the 24.30. And I am going to divide it by the mass of the compound, which is going to be 148.32. And I'm going to take it times 100. So in my calculator then, 24.30 divided by 148.32 times 100, and I'm going to end up with 16.38% magnesium in this compound. Well, if I want to find the percent of nitrogen in this compound, I'm going to do the same thing, but in this compound, I'm going to have 28.02 grams of nitrogen. I am going to divide that by the 148.32, which is the total mass of the compound, and I'm going to take it times 100, and I'm going to punch those into my calculator. And again, cell phone calculators work, or Google calculators work if you don't have a calculator readily accessible. And so I'm going to come up with 18.891, so I'll just go 89%, and this is percent nitrogen. And the last part, I need to figure out my percent of oxygen. And my percent of oxygen, again, is going to be the oxygen in the compound. So this is going to be 96.00. I'm going to divide it by the mass of the compound, which is going to be this 148.32. And any percent is going to be times 100. So my percent of oxygen is going to be 96.00 divided by 148.32 times 100. And I am going to come out with 64.724. So we're just going to say 72. And that's going to give me percent of oxygen. Hang on, I want to check my math here because one of my numbers doesn't work out here. Oh, wait, no, I think my numbers work out. Okay. So, questions.